Hi, I'm Phil Bainbridge, and this is a demo video for the blog post Exponential Backoff. As mentioned in the post, I was experiencing an issue with the rate limit and the calendar API when trying to update the guests of a calendar event. So what I needed was a way of introducing a pause or a sleep into my code so that it could retry again after a certain period of time rather than just failing and it having to involve a manual process. This is one way of using exponential backoff, and I just want to take you through a little bit of the code to explain how I've implemented it and set it up. We do have two functions, and we'll start with one just called main function. I've got some logging going on here just so we can see whereabouts in the process that we actually are. And then I've got a try and catch. Try and catch being a way of controlling any errors that happens in your code. You can basically catch that error and do something with it, whether it's logging it, producing a pop-up, sending an email, something to a user. It allows you to control an issue rather than the code just breaking down. So first of all, we start with a variable that in this instance I've called count. You might call it counter or something like that if you want. And it's how many times we should iterate through our loop when we encounter our error in order to retry it, basically. I've set it to 3 at this point, and you can set it to some whatever you want, basically, depending on how many times you want this to retry. Then we've got our variable, in this instance called backoff, but it's actually our delay, how long the code should wait before trying. Now, this is going to use utilities.sleep, as you'll see later on, so it needs to be a value in milliseconds. So at 2000 in this instance, it represents 2 seconds. That's going to be the starting delay, and it will double every time, as you'll see. Then we have our child function as it is, called test backoff. So we're going to pass the count and the backoff variables into that function. And for purposes of, again, logging and checking we know what's happening, we're going to return a message, which are going to capture in a variable called return message and just log that there. If any of this goes wrong, we've got the catch, and the catch will display an error message when that kicks in. So let's have a look at what the test backoff function does. If we jump down here, then we can see those two variables that we've passed in, and we're going to house all of this in a while loop. So everything that we've got going on down here, our while loop ends there. So what we're saying is, while our variable count, which we set to 3 in this instance, whilst it's greater than 0, keep trying what's happening below. So let's see what we've got going on. We have another try and catch, because again, what we've got here in reality would be the calendar API line that I was trying to update that could be causing our error. Now, what we're actually using in this instance is I'm creating an error manually, an error that actually matches the one I was getting, because I needed to be able to test this code isolated in its own right by kind of hitting the run button nice and easily each time, rather than plugging it into a big tool and script that takes a while to try to reproduce. Well, basically, we're using math.random to produce a number, and we're saying if that's less than 0.5, throw an error message with this pattern in it. Now, for reference, 0.5 gives us a 50% chance of this actually happening. Now, if I changed it to 0.9, for instance, and save that, there's a 90% chance that I can get this error message to generate now, which means I can then test the rest of the code that I want. So I'll leave that at 90% at the moment because I'm going to want to run the code shortly. So if this doesn't happen in our 90 kind of percent, so the 10% of the occasions where it's perfectly fine, we're just going to return a success message there, basically. Anything you want. In this instance, it's just successfully got file, just for something I was trying out. So you can have the return whatever you wish. And as you'll see up here, that is what will get logged. Now, if this kicks in and we have a failure, then we can use our catch and do something interesting here. So the first little bit that we're doing here is we're querying the error code that comes in, the error code we've created manually here, for some keywords. Because with code, you could have lots of different error codes, and I only want to specifically target the one called rate limit. That's when I want my exponential backoff to occur. So I'm looking at the error code and seeing if the words rate limit exceeded appear. If they do appear, I'm just going to log a message to say that a match has been found. I'm going to decrease our counter variable by 1 because at the end of this, we're going to have gone through our loop process once because we've hit the rate limit error message that we're expecting. Now, a quick bit of code in there. If our counter is at 0, that means we've gone through these loops as many times as I've specified, which is 3 in this instance, and I want it to stop because I don't want to get stuck in an infinite loop where this just keeps going and going and going. So what I've got is a little bit of code here after we've decreased that value to basically use the JavaScript method throw to pass that error message that we captured in here, which is this error message in here. So it's all lining up for us back to our parent function. So it will throw that back up the chain, which means it goes back up to here. And then it appears in the catch there because it's an error message that's come back. So in actual fact, it'll say catch error is here. It will jump to this line because of how we're throwing it back up. Okay. If our counter's not at 0 yet, so it's like the first time we're running through the loop, then obviously that's where we want to do our backoff. So what we're going to do is we're going to use utilities.sleep and set it to sleep for our backoff period of time, which, as you saw at the beginning, was set to 2 seconds to start with. So the code will sleep for 2 seconds. Then it will double the backoff length. So 2 seconds will become 4 seconds, will then become 8 seconds, 16 seconds, etc., up until the number of times we've asked it to count along. So what we don't want to do is we don't want to keep pausing it only by 2 seconds, for instance, if that's not long enough for the API to have its rest and then let us update it again. So we're increasing it to give it a greater chance. But we also don't just want to start at 30 seconds straight away because that might slow our code down too much instantly, unnecessarily. And just a quick failsafe here, if we were to get a different error message, then that's going to throw a different error, which in this instance, we're not going to test this line of code. But as I say, in reality, you may have more than one type of error message in your code. So this will throw that back up to the top as well. So you could do something different, like not go through this sleep and exponential backoff process. So let's jump back to the up here, where we've got 90% chance of this error message occurring. So let's run the code and see what happens. So we've got some logging going on. And the good news is we've got the error approaching because it's got 90% chance of actually happening. So if I match up the logs with our code, we can see the first thing we did was we just started the process. That is that line there. Then if we scroll down, we actually logged the count, which is count is, and 3 was our starting value. Next, then it's going to come and produce our error message here. Now, if it produces the error message, we're going to jump into our catch here, and our next bit of login is message match found, which is that line there. So it is triggering our manual error message. It is finding a match to the words that we've got, and that bit of code is running. Now we don't have any other login really going on there. You could put some in if you want to, but what we have happening next, as I say, is count is 2. So what it's gone down here done is decrease the count. It's had its sleep. As you'll see, it was 29, and then 2 seconds later, 31. Is it going back up to the while and starting again? So we got count is 2 this time. The error message is triggering, and you can see this time we've got a 4-second delay. And then we're triggering until we run out of time, basically. What's happened is we've run through our numbers of counts because there's a 90% chance of it occurring. So it finally throws that error message back up here, which is our parent function was called main function, and it actually jumps into the catch here, which I've started with catch error is, and you'll see catch error is. So let's just do the opposite there and make it so this is only 10% likely to happen so that we see what happens straight away when it runs perfectly fine. There, so very quickly, we started the process as our parent function. We log the count, and this time we're triggering this bit of code here. Return messages successfully got the file. So no exponential backoff has occurred because this bit wasn't true. It didn't trigger the error message because we changed the probability of it so much. So it allows you to tweak this quite nicely. But I say that's kind of one way then of implementing an exponential backoff. Thank you very much.